So I have here sort of the second derivative test written down, and I have a make-believe function. Yeah, I know that this equation is much, much simpler than the ones you're looking at, but the point of this video is to communicate the strategy, not necessarily how to find complicated derivatives. So here, let's find the first derivative, and you set it equal to 0 so that we can find what are called the critical numbers. It has this factorization, and so we get back 6 and we get back 1. So now what are we supposed to do? We're supposed to find the second derivative, and so we shall. Now look, do I have to find the second derivative? Yes. Do I have to set it equal to 0? And do I have to find like a number line? You don't have to do all of that. You don't have to. All you got to do now is do what the test says. You want to take your critical numbers C and you want to plug them into the second derivative. So f double prime of 6. So let me take 6, my critical number, and plug it into the second derivative. This is a number that is greater than 0. The actual value of it, I don't care. I just know that this is a number that's positive. So because the second derivative is greater than 0 at that critical number 6, according to these rules, we have a minimum at x equals 6. Now, what about the other one? Let's take the other critical number, which was 1, and plug it into the second derivative. And that number is going to be negative, so it's going to be less than 0. And according to the rules, because the second derivative is negative, we're going to have a maximum at x equals 1. And that's how you make the conclusions about the maxes and mins by using the second derivative test. Notice that I never took the second derivative and set it equal to 0. When would I have to go second derivative equals 0? You would have to do that for sure if you were trying to find the intervals of concavity. If you were trying to find concave up and concave down, then you're going to do this, where you set the second derivative equal to 0. But if all you're trying to find are the maxes and mins, you don't have to find the points of inflection. Just take your critical numbers, plug them into the second derivative, and follow the second derivative test. However, before you leave, one more thing here. Let's just pretend that x equals, let's say 7/2. Let's just pretend that this was a critical number. It's not, I know, but just for the sake of clarity. So let's pretend that this was a C value. So let's find f double prime of 7/2. And if I plug that in there, notice that here you actually get back the number 0. So in this case, whenever you get a critical number, that if you plug it into the second derivative and you get 0, it's inconclusive. The test fails. So what would you have to do in that instance? In that instance, what you would have to do is, as the notes say, you would actually have to go to your first derivative. You'd have to go to the first derivative number line, and you'd have to do these things here where you make cuts and then you pick test values. I'm just making this up. It's probably not true. But you'd have to go to the first derivative number line, and you'd have to do all these test points to see if it goes from positive to negative or negative to positive in the first derivative. And in the first derivative, if you go from positive to negative, it's a max. If you go from negative to positive, it's a min. So that's how you can use the second derivative to find maxes and mins.